Alright, so this one is 7.2, solve linear systems by substitution. So like I said, the last one was graphing. We had to find the point by plotting the points, graphing it, hoping it intersected, and we could tell exactly where it intersected. So now we're going to be doing it without a graph, okay, by the method of substitution. So we've got a few steps here to doing this. So steps to solving by substitution. All right, so the first step is to solve one of the equations for one of its variables Okay, a little hint here. You should have already done so on Google Classroom.
Oh, I mean like physically?
Oh, no. When possible, solve for the variable with a coefficient. Okay, so remember, coefficient is the number in front of the variable with a coefficient of 1 or -1. Next one, substitute the expression from step 1 into the other equation and solve for the other variable. In step 3, substitute the value from step 2 into the revised equation from step 1 and solve. And then remember to write the solution as an ordered pair. Okay, just like you did with the graph, just because you don't actually have a graph does not mean that that changes the way that we write the answer. And then check the point in the original equations. Once y'all have that, we'll jump into examples.
Can you do the examples below?
Yeah. Alright, so the first one I'm going to do is number 4. So the first equation is y is equal to 2x minus 1. And the second one is 2x plus y is equal to 3. Alright, so looking back, step 1 says to solve one of the equations for one of its variables. Okay, when possible, do it with one that has a coefficient of 1 or negative 1. Okay, in this case, they have already done step 1 for me. Okay, they already took care of that. I don't have to do it. Okay, they won't always do that, but to start out, they did that. Okay, so now step 2 says to substitute the expression from step 1 into the other equation and solve for the other variable. Okay, that's kind of wordy, but basically what it means is take this right here and stick it in wherever y is in this equation. Okay, sometimes you may solve for x initially and get the equation and it goes in for x, but this was y is equal to, so this whole thing on the other side is going into y. Okay, so this is where step 2 comes in. Okay, you don't have to label all the steps when you're actually doing the problems. I'm just labeling them for right now because that way you can see it on this first example and kind of what's going on. So I've got 2x plus, and I like to go ahead and put it in parentheses. Okay, because if there was a number in front of the variable, then we've got to distribute it through, things like that. So I like to just get in a habit of always putting it in with a parentheses. So 2x minus 1 is equal to 3. Okay, now I need to solve for x. I want to know what x is equal to. So how would I go about solving for x now? Okay, so I'm going to add these x's together. So that's 4x minus 1 is equal to 3. Now what do I need to do? Add 1. So 4x is equal to 4. And then what is x equal to? 1. So x is equal to 1. Okay, so I like to circle it so I don't lose it. Okay, so now step 3 is to take this and plug it back in to our step 1 equation, okay, the one that was modified. Now in this case, like I said, they gave it to us, so you did no modification, but it's easier to use the one that you modified. So plugging 1 in for x up here, so y is equal to 2 times 1 minus 1. So what is y equal to?
How did that change to 4?
Oh, because
They added the 2 x's.
yeah.
You're welcome.
2x plus 2x.
No, like equals 4.
Down here, because we added this one up.
Okay.
Yeah.
Oh, gotcha.
All right, so what is y equal to?
Wow.
1. So y equals 1. Now am I done?
No.
No.
What's wrong with it?
You have to put it in an ordered pair.
Put it in an ordered pair. So now that's my ordered pair. Am I done yet?
No.
Check it.
Check it.
And then graph.
We don't have to graph them anymore.
Little scroll.
Yes.
Not till the quiz. We don't have to graph them
Joey
again.
was so
No.
delayed, he went. Yes.
All right, so top equation. So I'm plugging in 1 for x and y. So 1 is equal to 2 times 1 minus 1. So 1 is equal to 2 minus 1 is 1. So it works in that one. And then the other one, 2 times 1 plus 1 is equal to 3. 2 plus 1 is 3. So 3 is equal to 3. So it's good. So 1, 1 is the ordered pair. That's the solution to this system. Any questions about this one?
No.
No.
All right. Number 6. 4x minus 7y is equal to 10, and y is equal to x minus 7. All right, so I'm not going to write in, okay, step 1, step 2, step, such and such. Is step 1 already done for me?
You have to make it.
Does one of the equations have a variable by itself?
The negative seven. Okay. Second one.
This one?
Yeah.
Yes.
So this is already ready for me to use.
No.
No.
Doesn't it have to be negative 1 or 1?
Wait.
No, I see why that's confusing though, when we haven't gotten to an example where we need that yet.
No.
We just need a variable by itself. As long as there's a variable on one side by itself, we're good. Okay, with no numbers in front, no symbols in front.
So it doesn't need to be a 1 or a negative 1.
It doesn't have to be. It makes it easier when we get to one that doesn't already have this done for us. Like if both equations looked like this top one, we would prefer for one of them to have a 1 or a negative 1 in front of it to help us solve it. We haven't gotten to an example that has that yet. Come on. All right, so x minus 7 is going in for y, okay, in that top equation. So I've got 4x minus 7 times x minus 7 is equal to 10. So I ultimately need to get x by itself, but I need to do some stuff before I can do that. So what is the first thing that I need to do with that left side? The order of operations.
Parentheses.
You have the x's.
I can't add the x's yet.
Parentheses.
Okay, so what about the parentheses are you wanting me to do? Distribute, yes.
No.
Okay, I'm distributing the negative 7, so, okay, I'm just copying down the 4x minus 7x. Now I have negative 7 times negative 7, so that's going to become positive 49 is equal to 10. And now what can I do?
Add the x's.
Add the x's, so 4x minus 7x is negative 3x. I'm going to go ahead and subtract the 49 all in this step just to save a line of work. Okay. So 10 minus 49 is negative 39. So what is x equal to?
X is equal to.
That's what I was just doing.
Like that.
366.
14.
4. Wait. 13.
13.
That's what I said.
No, you don't.
Okay, and they were both negative, so it becomes positive. Okay, I just circle it to keep up with it. It helps me to not lose where that number is. Okay. So now I'm taking this and I'm plugging it in up here to solve for y. So I've got y is equal to 13 minus 7. So y is equal to what? 6.
I knew that.
And how do I write my answer?
13,
13, 6.
13.
Okay, this is one you'd appreciate. I didn't make you graph.
Where'd you get the 6 from? Oh, never mind.
Oh my god.
All right, am I
We
done?
just said that 13 minus 7 was 13.
Am I done?
No, you have to check.
Check it, okay. Probably sounds like I'm being obnoxious when I continue asking if we're done or what you need to do, okay? But inevitably somebody will forget to check a problem, even though the instructions will say to do it, okay? So that's why I'm being super annoying about it. If I'm annoying enough, you won't forget it. All right, so I'm going to do the top equation. 4 times 13 minus 7 times 6 equals 10. It's 4 times 13. 52 minus 7 times 6. 42 equals 10. 52 minus 42 is 10, equal to 10. So that one's good. Now I need to do it in the other one. Let's see, y is 6, so 6 is equal to 13 minus 7. 6 equals 6, so it's good. All right, before we get into the type where it doesn't give you one of the variables already by itself to begin with, I'm going to have you guys try one. So I'm going to have you guys try number 8 real quick. Negative 5x plus 3y is equal to 51. And y is equal to 10x minus 8. Okay, so this one already has step 1 completed for you here. Okay, so take that and plug it in and see what you get.
You plug that in for y, correct?
Yes. Okay, I'll give you guys a couple minutes to look at that and then we'll go over it.
What is the Natalie to Eric? Is this going to do fraction or no fractions yet?
Huh?
There's no fractions in this kind of stuff, right?
I mean, some problems may have fractions, but I try to not give those ones.
Okay.
So no, this one, the answer should be whole numbers. Like, for example, number 17 in the book, the answer is decimals. Like, I wouldn't give you one of those. Not intentionally anyways. Sometimes it accidentally happens because I go switching numbers and forget to check it. But I try really hard to avoid those.
Stop singing, bro.
The sixth grade class worked with my mom in computer class. Sixth grade class worked with my mom in computer class. I sent her a link and you were put on it. Work is the James will never outgrow. Work actually is the phase you'll never outgrow.
He's alive.
That's not what that means, James.
No, I know, he's alive, but I found it easy to.
I'm like, I don't. First you understand what I meant, right?
Oh, yes, I understand.
Why would you?
Apparently not.
I did.
Huh?
How many days till 9/17?
9/17 is
Dude,
Friday.
it's on 9/17.
That's it.
You did not know that, James.
So
Did not know.
Friday, it's kind of an interesting situation. I won't be here Friday, and Miss Holloway can't do Friday. So I am planning to leave a quiz for you guys to do on those two sections. It's not something that I think, like, I'm going to go through the quiz beforehand and make sure there aren't any issues, but we have a volleyball game, so that's why we're leaving early. But Thursday will be a review day. I do have to leave about 15 minutes early on Thursday, but Miss Holloway is planning to come in for that last 15 minutes in case you guys do have questions. That way she can answer them. Obviously that may change like the other day, just depending on what's going on. But today and tomorrow will definitely be on this section. Wednesday will probably be a worksheet on this section, kind of like the one you had with the graphing. And then Thursday we'll do review in class, and then Friday we'll have a quiz.
On what, James?
On this one, I got x equals 1. What do I do now?
You plug it in.
Well, you should have gotten something, yeah. So then you take that value and plug it into that y equals equation.
Oh,
So
I'm checking
either
your
me
work.
and
You're
Maggie are
checking
both
your
right or we're both wrong. We got the same thing. Bull.
Y'all got the same thing, or you're saying you got the same thing as him?
No, we got the same thing.
Oh, okay.
If I got the same thing as James, it would probably be wrong. So.
I'll be right.
Shut up, James.
As long as you plugged it back in and checked the ordered pair.
Did you plug one back in,
I
James?
have to do that. On which equation?
No.
On which
Yeah.
one? There's two.
Oh my god. Chris, can you give us some tutoring in or Discord,
Chris,
please?
which one do I plug it back in? The second one or
Dude,
the
this
first
is
one?
like the
First or second one?
I'm bad at this.
Oh,
James, do you need help?
do I plug it in the first one or the second one?
Which one did you solve?
This is the first one.
Wait.
Stop copying my work. You see what?
Why would he copy someone who's wrong?
He's literally doing it right now.
Joe, if you're gonna copy someone, copy the girl who was the right answer.
Did you have the same answer?
Just in.
Me and her know what the same answer.
Oh, please.
I was the answer right.
Oh, what is it?
None of your business. Are you sassing me?
Oh, yeah.
James Worsham Abbott, are you sassing me?
My name was on
I hope you get hit by a bus.
Wow.
And I will make sure Joey's in with your people.
Nah, I tell you.
Yeah, I can.
Yeah.
What if I locked you in your house, Joey?
He's fine with me.
He's gonna climb up the chimney? What's he gonna do, Santa Claus? Barricades.
Sounds familiar.
What would you do?
All right, how are we doing with this problem?
I'm
Not
Great. Yeah, great.
We ready to start going over it?
I got
Yes.
All right, so like I said, step one's already done for you. This stuff here is getting plugged in for y in the top equation. So negative 5x plus 3 times 10x minus 8 is equal to 51. Okay, so I need to distribute this. So negative 5x plus 30x minus 24 is equal to 51. Okay, I need to combine these like terms, so that's going to be 25x, and I'm going to go ahead and add this 24 over, all in the same step, again, just to save a line, is 75, so x is equal to 3. So now I'm taking this and plugging it back in here, okay, so that I can get the value for y, so y is equal to 10 times 3 minus 8. So y is equal to 30 minus 8, which is 22. So my ordered pair is 3, 22. And then checking, got negative 5 times 3 plus 3 times 22 equals 51. Negative 15 plus 66 is equal to 51. 51 equals 51. And then in the other one, 22 is equal to 3 times, or well, I guess it's 10 times 3, but I wrote it backwards. Oh well. So 22 equals 22. So we're good.
How'd you get 1?
I subtracted it instead of adding.
Okay. Now, one thing I will say is the instructions in your book don't say to check it. But I am telling you, you have to check it.
Joey, check it.
Okay? Again, the beauty of checking guarantees that your answer is right. Okay, now, let's suppose in this scenario, let's say you got 3 and 20 somehow.
So you got 1.
Okay? Or, yeah, let's use that example. Okay, you got 1 for X. Okay? I'm not picking on you. I'm just using an example. Okay? You go to do your check and you can't figure out where you went wrong. You go back and you look at your work and you're like, I know something's wrong because obviously my checking isn't coming out to be right, but I can't figure out where I went wrong in my math. Make a note. I checked it. I know this point's wrong, but I can't figure out where I went wrong. Okay, that tells me that you did go back and look, you tried, and I usually don't take off quite as many points when you tell me, hey, I know my answer's wrong, but I can't figure out what's wrong with it.
Wait, so you grade for accuracy?
Well, yes, on quizzes and tests I
But
did.
no, I thought you meant like on homework.
Oh, no, homework is just do your best and,
Forget the rest.
as long as you're actually attempting and making a good solid attempt at it, I'd count it.
Okay.
Okay.
Everything I do is a good solid attempt, except for when it's not. No.
Yes, that's fine.
Yeah, but you don't understand this.
Yeah, I do.
I understand it.
Wait,
Um,
Mr. 1.
I subtracted instead of adding.
Okay, so I think what we're going to do, there's about 15 minutes left, and I want you guys to have some time to start on these problems. Okay, again, we're finishing the section tomorrow. I'm going to do the other type tomorrow where you don't start out with something like this that's already got one of the variables solved for. Okay, so tomorrow we'll go into the ones where both equations look like this top one here. Okay, and we have to get something by itself. So, what I want you to do for the last 15 minutes is to work on problems
1 and 2.
5,
You're wrong.
7,
You asked me. Ask me what she- Oh, you did worse. I don't understand how you
and 9. 9 I'm going to tell you because it's a little different than the ones we had. I'm going to set up the equations for you. Okay, so for 9, it was 2x is equal to 12 and x minus 5y is equal to negative 29. Okay, the top equation modified is going to be x is equal to 6. Okay, so use this in this equation. Now, that should be an easy substitution because in reality, they've actually already done step 1 and step 2 for you. You just have to find the variable here of what y is equal to. Because it's not exactly set up like the ones we did today. So I wanted to just go ahead. Yes, I do think that y'all could have figured out what x was equal to if I had just given this to you. But because it's not exactly like what we did, I wanted to go ahead and modify it for you. So you're using this equation here and this one here, okay, to solve 9. Okay, so work on those for the last 15 minutes, and then tomorrow we'll do the other type, and then Wednesday we'll do a worksheet with this.